The Moon, unlocking Earth's past and humanity's future. The Moon, Earth's only natural satellite, is far more than a familiar object in the night sky. It is the oldest witness to our planet's history, a silent archive preserving the story of Earth's formation and evolution. For thousands of years, humans have gazed upward at the Moon with wonder, mythology, and imagination. Yet only in the modern scientific era have we begun to understand how profoundly the Moon has shaped Earth, and how vital it may be to our future beyond our home planet. 1. A scientific overview of the Moon. The Moon has a diameter of approximately 3.474 kilometers, about 27% the size of Earth, and a mass only 1/81st that of our planet. As a result, lunar gravity is just 17% of Earth's gravity, allowing objects and astronauts to weigh far less and move with extraordinary ease. The Moon orbits Earth once every 27.3 days and rotates on its axis at the same rate. This phenomenon, known as tidal locking, ensures that only one hemisphere of the Moon is ever visible from Earth. The far side of the Moon remained completely unknown until the dawn of the space age. Unlike Earth, the Moon has no substantial atmosphere, no global magnetic field, and no liquid water on its surface. These conditions mean that lunar landscapes remain largely unchanged for billions of years, making the Moon one of the most pristine geological records in the solar system. 2. Humanity's exploration of the Moon. Human exploration of the Moon began in the mid-20th century, during the intense technological rivalry of the space race. In 1959, the Soviet spacecraft Luna 1 became the first human-made object to fly past the Moon. Later that year, Luna 3 transmitted the first-ever images of the Moon's far side, revealing a terrain strikingly different from the familiar near side. The defining moment in lunar exploration came on July 20, 1969, when NASA's Apollo 11 mission successfully landed on the Moon. Astronaut Neil Armstrong became the first human to step onto another world, delivering the historic words, "That's one small step for man, one giant leap for mankind." Between 1969 and 1972, 6 Apollo missions landed astronauts on the Moon, returning more than 380 kilograms of lunar rock and soil. These samples revolutionized planetary science and transformed our understanding of both the Moon and Earth itself. 3. How did the Moon form? The mystery of its origin. The most widely accepted explanation for the Moon's formation is the giant impact hypothesis. According to this theory, about 4.5 billion years ago, the early Earth collided with a Mars-sized protoplanet, often called Theia. The immense impact ejected vast amounts of molten material into orbit, which eventually coalesced to form the Moon. However, this theory does not fully explain one major mystery: the dramatic asymmetry between the Moon's near side and far side. A newer hypothesis suggests that Earth may have once had 2 moons. In this model, proposed by scientists such as Eric Asfog and Martin Jutzi, a smaller companion moon slowly spiraled inward and collided with the larger moon at very low speed. Instead of forming a massive crater, the smaller moon was gradually absorbed. This gentle merger could explain why the Moon's near side is thinner and smoother, while the far side has a thicker crust and higher mountains. Although still debated, this hypothesis offers a compelling new perspective on lunar evolution. 4. Solar and lunar eclipses, a precise celestial alignment. Solar and lunar eclipses occur only when the Sun, Earth, and Moon align almost perfectly. A solar eclipse happens when the Moon passes between the Sun and Earth. A lunar eclipse occurs when Earth moves between the Sun and the Moon, casting its shadow across the lunar surface. Because the Moon's orbit is tilted about 5 degrees relative to Earth's orbit around the Sun, eclipses do not occur every month. Instead, they happen only when the Moon crosses specific orbital nodes. These events repeat in predictable patterns known as the Saros cycle, which lasts approximately 18 years, 11 days, and 8 hours. Importantly, the Moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. In roughly 600 million years, The moon will appear too small to fully cover the sun, and total solar eclipses will disappear forever from Earth.
5. Lunar soil, an alien material. The moon's surface is covered by a layer of fragmented material known as regolith, created by billions of years of meteorite impacts. Apollo astronauts discovered that lunar dust is extremely fine and sharp-edged, clings stubbornly to suits and equipment, can remain suspended above the surface despite weak gravity. Modern research reveals that lunar regolith contains nanoparticles trapped inside glassy bubbles, formed when meteorite impacts melt surface material. These nanostructures give lunar soil unusual properties, including high thermal insulation and low electrical conductivity. 6. Lunar dust, a hidden health hazard. Studies conducted by researchers at the University of Tennessee indicate that lunar dust may pose serious health risks to humans. When inhaled, sharp dust particles can irritate and damage lung tissue, cause chronic inflammation, potentially increase cancer risk during long-term exposure. This poses a significant challenge for future missions, especially those involving extended human presence on the moon. 7. Is the moon still geologically active? Images from NASA's Lunar Reconnaissance Orbiter, LRO, have revealed narrow, elongated trenches called graben on the moon's surface. These features form when the lunar crust stretches and fractures. Surprisingly, some of these structures may be less than 50 million years old, suggesting that the moon is not entirely geologically inactive, as once believed. 8. Helium-3, the moon's energy treasure. The moon is thought to contain up to 500,000 metric tons of helium-3, a rare isotope on Earth but highly valuable for clean nuclear fusion energy. On Earth, only a few dozen grams of helium-3 can be collected annually. On the moon, however, it has accumulated for billions of years due to the lack of atmosphere. Despite its promise, the enormous cost of extraction and transport makes helium-3 a long-term rather than immediate energy solution. 9. Humanity's future on the moon. Several space agencies, including NASA, Roscosmos, and JAXA, are developing plans to establish permanent lunar bases, use the moon as a stepping stone to Mars, test advanced technologies, including lunar elevators and in-situ resource utilization. Within the coming decades, humans may live and work on the moon for extended periods. The moon is far more than Earth's companion. It is a preserved record of the solar system's earliest history, a natural laboratory for planetary science, a strategic gateway to humanity's future in space. Right finger to understand the moon is to understand Earth, and the path humanity may one day take beyond it.